To solve this piecewise limit problem, the easiest thing to do is to imagine these functions sitting on the left and the right hand side of the number line. So here we're going to x equal 2. And on the left hand side, or less than 2, we have the equation x squared plus 1. And on the right hand side, you have the equation 3x minus 1. To find the limit, even as a piecewise function, we need to have each of these two equations approach the same value when you get x equals 2. So the best way to do that is to plug in just 2 in for x for both equations. So you plug in 2, so it's going to be 2 squared plus 1. So 2 squared is 4, 4 plus 1, 4 plus 1 is 5. So the left-hand side is 5, so we do the same thing on the right-hand side. So if you have 3, this time is going to be times 2 minus 1. This is 6 minus 1, which is also 5. And because they are the same value, then we know that the limit of this function is equal to 5. For this problem, we do the same strategy. We visualize the number line where our x value is going towards 1. From x is less than 1, we have the equation 2x plus 3. And then x is greater than 1, we have the equation x squared plus 4. Now we plug in an x value of 1 for both functions and see if they are the same. So over here we have 2 times 1 plus 3. So it's 2 times 1 is 2. So we got 2 plus 3, which then this equals to 5. And on the right-hand side, we have 1 squared plus 4. 1 squared is just 1 plus 4. This also equals 5. Therefore, the limit of this function is also equal to 5. For this piecewise limit problem, same strategy. Draw a number line, testing x value go 2. So the function for less than 2 is 4x minus 1. For function greater than 2 is x squared. Plugging those values in, you have 4 times 2 minus 1. So 4 times 2 is 8. So you have 8 minus 1. So you have 7 coming from the left-hand side. And on the right-hand side, we plug in our function 2 squared, and we see that this gives us the value of 4. So on the right-hand side is approaching 4. Because these limits are not the same, the answer does not exist. For this piecewise function, even though there's 3 pieces, we use the same logic. We visually draw a number line. We are testing the value as x is equal to 3. The function on the left is x squared minus 9 over x minus 3. The function on the right is greater than 3 is 6x minus 18 over x minus 3. So for both functions, we first have to algebraically manipulate them. So for the function less than 3, the x squared minus 9, we're going to rewrite the top as x minus 3, x plus 3, all over x minus 3. So then we see the x minus 3 cancels out. So the left function is just x plus 3. On the right-hand side, we're going to factor out 6, giving you x minus 3, all over x minus 3. So we see that the x minus 3 is canceled out. So it gives you the value of 6. On the left-hand side, we still have to plug in a 3 in. So we got 3 plus 3, which just gives us 6. So we see that the left hand function and the right hand function both produce the same thing. So if we visualize it, we're not sure exactly what it looks like, but we know that it approaches a value of 6 here from the left. Same thing on the right hand side, approaches 6 here from the right. And then the third piece, that's just saying that we have a dot at exactly 6 on the x value of 3. So we actually fill in those dots. But notice that the third function has no bearing on what the limit value is, because again, the limit only concerns about where the two functions are heading, if they're heading to the same value as they're approaching